Hi everyone, welcome to your notes video. This is for lesson 1.1 on rational numbers. Our learning target is to understand absolute values and being able to put their values in order. You'll know that you have met these success criteria if you can graph rational numbers on a number line, if you can find the absolute value of a rational number, and if you can use a number line to compare rational numbers. We have a few key vocabulary words to look at first. An integer is any number that could be seen on a number line, whole numbers, including their opposites. So examples would be -5, 7, 12, and then of course all their opposites, 5, -7, -12. A rational number is any number that can be written as a fraction or any decimal that repeats or ends. So 3, it's a whole number, but it could also be written as a fraction, 3/1. 2/3, that is a fraction, so that's rational. A decimal, 2.5, it has an ending. Or 0.625, where the 5 repeats. Those are all considered rational numbers because they can be written as fractions. Our last vocabulary word is absolute value. That is the distance between a number and 0. So the absolute value of 3 is equal to 3 because on a number line, the number 3 is a distance of 3 away from 0. Now there is one other little particular situation that can get a little bit tricky, so I want to give you another example here. If I were to give you minus absolute value of -4, we're going to look at this and we're going to say 0 and -4. We're going to say the distance from 0 to -4 is 4. But this symbol out front means opposite. So in this situation, the opposite of the absolute value of -4 means we have to then take our negative sign out front and we have to apply it back to the number. So for another example, find the absolute value of rational numbers. Let's find the absolute value of -3 using a number line. Here is 0, and there's -3. -3 is a distance of 3 away from 0, so therefore we would say the absolute value of -3 is equal to 3. Sometimes we'll take the absolute value of a rational number, in this case 1 1/4. We can still use a number line because here's 1, and then if we split this up, there's 1 1/4. The distance between 0 and 1 1/4 is 1 1/4. So we would say the absolute value of 1 1/4 is 1 1/4. So keeping in mind that absolute value is just the distance a number is from 0 on the number line, you try these 3 on your own. Find the absolute value of 7, the absolute value of -5/3, and the absolute value of -2.6. And then push play when you're ready for me to show you the answers. Starting with number 1, please note you can put the number 0 anywhere you want on the number line, and in this case I moved it over to the left because I know I'm going to have to add the number 7. So here's my number 7. The distance between 0 and 7 is 7, so the absolute value of 7 is 7. -5/3. This time I'm going to put my 0 over to the right side, and I'm going to say this is negative 1/3, negative 2/3, negative 3/3, negative 4/3, and negative 5/3. And the distance between negative 5/3 and 0 is 5/3. So the absolute value of negative 5/3 is positive 5/3. And finally, negative 2.6. There's negative 1, negative 2, and negative 3. So negative 2.6 is going to be in the middle there somewhere. And we'd say the distance between 0 and negative 2.6 is 2.6. So the absolute value of negative 2.6 is just 2.6. For these next examples, we're going to compare rational numbers on our number line. So let's start by comparing the absolute value of negative 1 compared to the absolute value of negative 4. If we were just to plot these, negative 1 and negative 4, you may be tempted to say that negative 1 is larger than negative 4 because it's further to the right on the number line. It is a bigger number. But let's not think that way right now, because what we actually have are absolute values. So let's first of all think about the absolute value of negative 1. The distance from 0 is 1. So the absolute value of negative 1 is actually 1. The absolute value of negative 4, the distance it is from 0, is 4. So our absolute value of negative 4 is equal to 4. What we're actually doing here is comparing 1 to 4. And in this case, 4 is clearly bigger than 1. In our next example, we'll compare negative 2.5 and 32. Now, some of you right away might be thinking about this one and thinking, well, wait a second, I already know which one's bigger. And I hope you do. Without even drawing this out, I want you to notice that the absolute value of negative 2.5, that is the distance a number is from 0, is going to be 2.5. So we could say the absolute value of negative 2.5 is 2.5. Well, how does 2.5 compare to 32? 2.5 is obviously much less than 32. So we would say 2.5 is less than 32. And now that you've seen a few of those, go ahead and try these 3 on your own. Make sure you're thinking through this logically, and make sure you're finding the absolute value of these numbers. Once you're ready, push play, and I'll talk you through these. So let's start with absolute value of 9. That is the distance a number is from 0. So we know that the absolute value of 9 is equal to 9. Negative 9, so if we say this is 0, negative 9 would be way out there. Well, the distance that is from 0 is 9. So how does 9 compare to 9? Technically, those are equal. Number 2, we had to remember that this time the negative sign is actually outside, and we have to know that sometimes that little dash that makes us think of subtract or negative can also mean opposite when it is on the outside of absolute value symbols. So we would know that the absolute value of 1/2 is 1/2, but the opposite of that is negative 1/2. So we're now actually comparing negative 1/2 to negative 1/4. So we have to think which of those is further to the left. That's a little bit challenging in this case because we don't have common denominators. So let's go ahead and change those. Instead of 1/2, let's make that 2/4. And now when we draw our number line, we'd have -1/4, -2/4. And we can see that -2/4 is further to the left, -1/4 is further to the right, so -1/4 is larger. And then for this last try it, we have just the whole number, 7, and then we have the absolute value of -4.5, plus we're taking its opposite. So let's just think about the -4.5 first. Let's plot that -4.5 so we can find its distance from 0. So there's -4.5. And the distance -4.5 is from 0 is 4.5. But we have that opposite out front, so we need to say negative. So now we're just comparing 7 to -4.5. Anytime we have two numbers that we're comparing here, anytime we have two integers, and one is negative and one's positive, we obviously know the positive is going to be greater. For our last example for today, we're modeling real life. A moon has an ocean underneath its icy surface, and scientists run tests above and below the surface. The table shows the elevations of each test. Which test is deepest? Which test is closest to the surface? So the deepest test is going to be the test that is furthest into the negative. So we're going to plot all of our numbers. -3.8, -5.15, 0.3, -4.5, and -0.25. So now that we have this visual, we can see which is the deepest. Deepest is going to be furthest to the left, which is the -5.51. So we would say that the salinity test is the deepest. But now for which one is closest to the surface, what we need to do is determine the absolute value. So we're going to compare the absolute value of 0.3 to -0.25. And in order to do this, we're going to want to add a 0 in because now we're comparing 2 digits of decimal to 2 digits of decimal. And we can clearly now see that if we are 25 hundredths away from 0, that is closer than 30 100ths away from 0. So in this situation, we would say that ice is closest to the surface. Now to wrap up the lesson, let's have you try one last problem. An airplane is at an elevation of 5.5 miles and a submarine is at an elevation of -10.9 miles. Which is closer to sea level? And explain. Once you've attempted this problem, go ahead, hit play again, and I'll show you the answer for your last try it. All right, so for this one, let's make a number line over here. And on our number line, we'll have 0, which is sea level. 5.5 is going to be up here. And that is where our airplane is. And then negative 10.9. I'm going to have to extend my number line. So there's negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's negative 10.9. That is our submarine. So this is an absolute value problem where we are comparing the absolute value of 5.5 to the absolute value of negative 10.9. But it's much easier to see it on a number line. We can see the distance from sea level to the submarine is much greater than the shorter distance from the airplane to the submarine. So we would say, which is closer, the airplane. And that wraps up your lesson for Chapter 1, Lesson 1. If you still have questions, please reach out to your teacher. Otherwise, good luck on your practice.